All right, so here's our brief foray into human system interface design and user experience. Also, we'll touch on some topics from human-computer interaction as well. Okay, so first step uh, is to get some definitional clarity. So uh, one thing you will find out when you're starting to dig into these disciplines is that there's a lot of acronyms that get used moderately, kind of interchangeably. So the big ones are HCI, HSI, and HMI. So, and these are kind of their definitions there. Um, but it's really one of those. HCI is a specific discipline more broadly, where HSI or HMI might be used to describe the actual process or practice of designing for systems. Um, but what we run into, right, is the bullet point down here. What about if everything is a computer system and machine simultaneously? How do we do that? In this course, we're going to refer to it as HSI, largely human system interaction. But in a broader sense, sometimes human-centered design might be a better terminology to use. It's really just kind of depending on your use case. And as with a lot of things in this course, right, you want to generally align with whatever disciplinary or topical space that you happen to be working within. Okay, so first, this is a really important topic to understand for just how humans perform in our digital world. So it's this principle of design inheritance. So when we refer to ubiquitous computing, that's the kind of era, we could say, of computation that we are in, where everything is a computer or has, the vast majority of things have some kind of a compute process. And so what that tends to mean is that nearly all devices will have some kind of a human experience and therefore an HSI concept. Now, what does this mean for nuclear or other critical infrastructures, right? That means that your system will need to align with user expectations, which are now kind of defined everywhere. So that's why when you browse the internet, right, certain types of sites tend to look similar. Certain applications that are in a similar space will be similar. And that's because everybody's trying to leverage everybody else's design work to get their user experience up. So what that means for us is that that is a larger design space for novel digital systems. So it's a potential increase in risks. As we design HSIs, we need to be wary of when we deviate from different designs that our users will expect. And then this is just an example from Nuclear Regulatory Commission, but you don't have to refer to this one. Depending on your discipline scope, there may be other examples of this, but New Reg 0711 is our human factors review model. So HSI modifications should be designed as far as possible to be consistent with users' existing strategies for gathering and processing information. So that's usually a big one when we look at more modern events and how we kind of perceive human performance in those spaces. It's important to understand, if the interface is really bizarre relative to other interfaces out there in the world, that is a risk to performance that we need to be aware of. Okay, so these are the main aspects of any HSI design and kind of their definitions. And then the sub-bullets here are various measures or methods you may use to kind of interact with that concept. So user experience, more common in commercial design, but it speaks generally to a user's satisfaction. So how satisfying is it to use, how seamless the interactions are, etc. It's important to note that in a lot of regulated environments, user experience isn't really referred to or used much because they don't really care if their Operators like what they do. They just want to know that they can do it. So that leads us into usability. So usability refers to the basic functionality and efficiency of the system. So it speaks to how usable the system is. It's not about if you like it or not, it's about can you do it. Then we move to information architecture. This is a bit more abstract. So this refers to how information is structured and discoverable within your system. So this will include hierarchies of information, menus, logical arrangement of data structures, those kind of things. This actually, oddly enough, tends to be a primary focus in library science programs, which may seem kind of surprising until you really think about what a library is, and that of course they would be the ones focused on how information should be structured and discoverable. But we do some of that when we're designing systems. And then finally, user interface. So this is the design of graphical elements within the HSI and the pictorial means of communication within a system. So this is will tend to be the more aesthetic side of things. How we design buttons and those kind of things to look good and to be usable. And those will be specific aspects that we look at for HSIs. There's specific laws, quote unquote, that we refer to in human factors and human-computer interaction more generally, and one of them is the Hicks-Hyman law. So the more choices that a user has increases the cognitive response time in a logarithmic fashion. It is a large consideration. Oh, my image is cutting off there. It's a large consideration in the design of like websites, applications, those kind of things. Since it's logarithmic, it's gonna top out at a certain point, right? So when we look at process interfaces or industrial, kind of the more critical spaces we're looking at more often in this course, it's not as huge of a focus, typically because the interface of some kind of a system or machine or things will likely have a lot of depth in what's available, and it's actually a design feature to maintain availability of as many different concepts or interactions as possible. So what that means for us is that reaction time's probably going to max out for our things because the potential choices a user has will be relatively significant. So as we're designing systems, right, the reaction time is something that we want to understand so that we don't require some task performance where the time required for that is lower than the response time, right? We want to make sure people have sufficient information, otherwise we are setting them up to fail, and that'd be a design flaw. Then we have Fitts law. This is more about navigation to an element in a digital system. So Fitts law says the time it takes to navigate to an element is a function of the distance from the cursor and the width of the UI element. So a bigger button, it will take less time to get to from anywhere on the screen because they're large. This is actually an interesting point of why everything on a lot of digital systems gets placed in the corners, why the X to close a window is in the corner, the start menu on Windows is in the corner. That's because they're infinitely wide. They can't be missed. So if you think about that, if you close your eyes and you got a mouse, you can always navigate to the corner successfully because you can always go to the right a lot and down a lot to get to the bottom right corner. So that's why a lot of important actions end up getting placed in those spaces. All right. Okay, direct manipulation. So this was a massive change in user interfaces with Windows 95. So prior to Windows 95, Windows 3.1 was still a command line style text interface largely, and Windows 95 was the first real operating system that enabled direct manipulation, which then supported the concept of a graphical user interface. So when we talk about direct manipulation, we're really referring to hacking the physical world into the digital. So if you look at, this is a very old image, right, of 95, but if you look at even modern ones, right, we have folders, there's a term of a desktop with stuff on it, we can drag and drop things, but what's important to remember, right, is folders don't exist. A desktop doesn't exist. A desktop, oddly, is just another location for data. And when we drag and drop files, we're not actually dragging and dropping a file. What's happening is that the GUI, the user interface, is issuing the move command in the background, which is just telling the computer to move this data over there into that different logical location. So a direct manipulation, because it's become so ingrained in everything, is a key expectation of all users. It is something you can expect to include and manage in your design. So what's nice is that it's a simple way for HSI designers to make use of learned behaviors. So by leveraging direct manipulation concepts and design principles, we can typically increase success on tasks just because we are making use of things they already know how to do and expect to do. And then this will be kind of peculiar, but stick with me. So there's predominantly, when we think about UI design and how we should design digital items, there tends to be two main schools of thought. One is skeuomorphic, and then much simpler to say, flat design. Skeuomorphic is when we lean on existing physical mental models and associations. So we are relying on our understanding of physical objects. So if you look on the bottom left here, this was an old instance of the Kindle, and it is displaying the applications here on basically like a forward-facing bookshelf. Obviously, Kindle was originally started as an e-reader platform, right? So that would track, but that was why, was because when we think about a physical bookshelf like this, you browse it, you navigate it in a physical world. So they were trying to leverage that to get people to understand how to interact with this. Similarly, in the middle here, or left middle kind of, this is an older version of the iPhone iOS interface. And some of the skeuomorphic stuff here is a little bit different. It's not presented in like a bookshelf style format, but notice the bottom, how there's a reflection in that bottom gray area, and then the mail phone, Safari, and camera sitting on that, but there's a reflection back up, which is trying to bring a user's attention to, this is some kind of a tabletop. And why is that skeuomorphic? Because everything else is just kind of floating up in the ether, but this tabletop is where the critical stuff goes. That was the idea. Also, you'll see it where we're trying to leverage like visual processing aspects. So notice how these on this iOS version, the items will have shadow drops and different things around them. That's to again, pop them out from the background. And keep in mind, these were designed at a time that broad mobile style interface concepts were not established yet. Now, the reason we don't use these sometimes is because it does increase your base cognitive load. There's a perceptual cost to paying attention to these constructs or shadows in an image, or the reflection in the tabletop. There's a cognitive draw on that. So then we ended up in flat design. So this the left of the bottom right is a screenshot of Windows 8.1 and the card-based structure that it had. And notice there's no shadow drops, there's no depth, there's no illusions of depth. And so, and similarly on the far right here is a more modern iOS style interface where, again, there's no drop shadows, there's nothing like that. It's a cleaner design and it relies on digital mental models and associations. Flat design is a lot more common now because a lot of those interface styles or principles have been established now. Most people know how to use those and know how to interact with the devices. So we didn't need to rely on the skeuomorphic realism. So again, there's pros and cons to both, and there's times to use both. And typically, user research and evaluation will inform which one is best for your use case. There's no specific immediate winner. There are realities like skeuomorphic will increase your cognitive load. There might be times where that's okay because the gains you receive in leveraging those mental models is valuable for your use case. And vice versa, there may be flat design where it's there. So again, from a usability perspective, there's some nuance. Then there are concepts called Gestalt principles. So this was from an early 1900s Germanic school of thought. Gestalt means pattern or configuration. And basically they're characteristics of human visual processing that we can use, that can have design implications. So, and this is essentially how our visual system works. So if we look at the example on the right, these are basically two images showing both are showing the same concepts. They're just showing them differently. I prefer this one here on the right. So we have proximity. Elements which are close together tend to get grouped together in our visual processing. We have closure, so the human brain will ignore gaps in a line and try to understand the broader shape. Similarity, elements which look similar will also be grouped together. Common region, so elements which are close together seem to be a group. This is slightly different from proximity because see the groupings, the boxes around these circles, that's why we use borders in a lot of interface design, right? We want to distinguish a region, and because we did that, our visual system will inherently group them within that region. Continuity, if we order something in a line or a curve, they get grouped together, etc. You can kind of see how this works. And what this means is if there are similar elements or elements that should be used together that are not grouped together, or they're not similar in certain ways, then we're kind of deviating from that. We want to try to leverage our visual processing and what our visual system will do regardless of what we tell it. This is, a lot of these groupings are subconscious. They're not things that you have active control over. And so it's important to design leveraging that whenever we can. And then we have Nielsen's usability heuristics. So these came about in the 80s and 90s from the work of Jakob Nielsen. And there's a ton, if you Google this, there's a ton of breakdowns of this, examples out there and those kind of things. But fundamentally, this is kind of expectations of what we consider good design. Like general principles that are almost always, 99.9% of the time, going to be present in a digital system in order for it to be functional. So they're relatively straightforward. There should be some visibility of the system status. It should be obvious in the interface what state the system is in, or component, or whatever you're looking at. There should be a match between the system and real world. That means in terms of feedback. When we take an action in the digital system, we should be able to perceive or validate change in our physical world. User control and freedom largely considers aspects like Control Z, undo, being able to allow users some control in this digital sandbox. Consistency and standards, right? If you refer or design something a certain way, or you refer to it a certain way, don't change it halfway through the interface. Be consistent there. Error prevention. So this generally talks about testing, and that's how we prevent errors in interfaces. Is we put people in real cases to use it, and we evaluate that, and then redesign or modify as needed. Recognition over recall. So notice these signs. The first one just says turn left. The upper says turn left. The other one says turn left with an arrow pointing left. That's because we try to rely on human memory as little as humanly possible. Flexibility and efficiency of use refers to multiple paths to success, right? And again, you'll test this out and you'll find users that will take dramatically differing paths to a success condition. And so being able to understand that and design for that is critical. Aesthetic and minimalistic design. So this is our visual system processes aesthetically designed things easier. There's a reason that we tend to like things that look nice. It's because our brain processes it to be clean and easy to understand. There should be help users with errors. So this is about error messages, right? When we give you an error message, it shouldn't just be a string of numbers and characters. It should be a descriptive explanation of what happened. And then finally, help and documentation should always be present so that if the user has questions, they can go and seek the answer out. And then as we look at, these are kind of tying back to some of the HF methods, but when we're looking at interface design, right, operating experience review is still important. We want to do structured interviews with operators to capture the context of work, especially if we're designing an interface that is supposed to enable or enhance that. Important human actions. So this is important to capture what are the critical steps, what are the things that your operator of this interface has to do that are the most important. Maybe it's a shutdown button or different things there. What are those critical steps? And so those should be designed with an eye towards making sure they're always available or easy to navigate to. And then verification and validation. So this is just a very thorough manner of ensuring that the design is good. There is a broad spectrum of how rigorous your verification or validation needs to be. So these will be kind of your final steps. You could consider them like factory acceptance testing or system validation, where we test operators in different conditions to make sure it will work when deployed out into the real world. And then be aware when we look at a lot of these, right? HPI tools. So what do those mean when we look in an interface, right? Self-check, peer check, walk down, stop when unsure. What are we talking about when we look at interface design? Similarly with just culture, see something, say something without retaliation. If somebody comes to you and says, hey, this interface is really janky, I don't like it, take that into consideration. And it's important to also understand that the vast majority of industries out there don't do things like this. They don't deploy HPI or human factors regularly or in a structured way. So in a lot of instances, there are events that could have been avoided with relatively low-cost interventions from a human factors or human performance angle, right? We learned years and years and years ago that fitting the work to the worker was far more efficient than fitting the worker to the work. So it's important to just remember as you look out on events and you might see things that are like, well, if they would have just used this wouldn't have happened. What's going on? That's because it's not common in a lot of those industries to use that. All right. So next week we're going to really dive into accident investigation and the steps and kind of process that works. And then we'll look at how do you evaluate human performance within that framework. Thanks.